Testing optimization in service ecosystems is an experimental project carried out by the Manchester Centre for Service Research at the University of Manchester within the project Bonfire. A service ecosystem is a dynamic virtual space where services exist. Services can appear and disappear at any time. Services can connect to each other, disconnect and reconnect. Usually, services in a service ecosystem are located across networks and distributed over geographical areas. Services come together to compose solutions on the fly. This is a scenario of the Internet of the future. But what is out there to support it? This is an example of a service composition. Each node represents an activity that can be done by a service, but there can be many suitable services for each activity. The problem is how to select the best combination of services given the dynamism of a service ecosystem. We have developed two optimization approaches. The SOA-for-all optimizer considers end-to-end connections between services. A genetic algorithm calculates the best combination of services. The DIME optimizer considers one-to-one connections between services represented by software agents. Through self-organization, the best combination of services emerges from local interactions. But what do we need to test the optimizers? We need on-demand resources to emulate the dynamism of a service ecosystem, geographic distribution of components, seamless communication of components to facilitate the dynamism, monitoring capabilities. Bonfire provides us with all this. Bonfire is an experimentation testbed and allows us to test a number of configuration and scenarios of service ecosystems. Our results show SOA-for-all is more scalable than DIME. But when we analyze continuous optimizations over time, DIME's output is more stable than SOA-for-all's. Bonfire has helped us to detect strengths, weaknesses and applicability of our optimizers. SOA-for-all is more suited for one-off optimization, such as that in online purchasing. DIME is more suitable for continuous optimizations, such as that of traffic control. With Bonfire, we emulated service ecosystems as a future internet scenario and achieved the characterization of our optimizers for real-world problems.